Percent composition of compounds. There are two common ways of describing the composition of a compound. One, in terms of the number of its constituent atoms, and two, in terms of its percentages by mass of its elements. So this is a percent composition problem, percent composition by mass. And this actually is historically one of the favorites of the AP exam to ask you at least some point, both on the multiple choice portion and on the free response portion. So the law of constant composition, or definite proportions, right? It's something described by John Dalton, if you remember that, states that any sample of a pure compound, any sample of as long as it's pure, can't have any other stuff in there, of a pure compound, always consists of the same consists of the same elements combined in the same proportions by mass. Remember, all percent calculations are simply whatever the part is divided by the whole multiplied by 100 to make it a percent. And so what it'll look like, more specifically for us, the percent composition, which oftentimes will be what we're calculating, we're going to have the total mass of the compound underneath the mass of the desired element, meaning the percent composition due to that specific element. Multiply it all by 100% to make it into a percentage. We're good to go. So, for example, let's look at ethanol, C2H5OH. You might wonder why it's not written as H6, because it's more important to the reader to recognize that OH, right? It's an alcohol, right? It's an alcohol functional group, and so it's more important to the reader to know that that's there than to know that there are 6 hydrogens, because we're all very astute and we recognize that there's a hydrogen there to add to these 5 hydrogens, so we actually have 6 hydrogens. So for every 1 molecule of this, we have 2 molecules of carbon, or for every 1 mole of this, we have 2 moles of carbon. So go 2 moles, multiply them by the molar mass of carbon, and so we have, in terms of mass, we have 24.02 grams of carbon. Doing the same thing for hydrogen, there are 6 moles of hydrogen in 1 mole of this. So 6 moles multiplied by the molar mass. Again, moles will cancel. Our only unit left will be grams. So I have 6.06 grams of hydrogen. Lastly, for oxygen, there's only 1 mole of oxygen for every mole of ethanol. And so I'll multiply that 1 mole by the molar mass of oxygen, 16. Now I'll take these 3 values and I'll add them together to get 46.08 grams. And so the mass of 1 mole of ethanol is 46.08. Why is that important? Because that's my number I'm going to stick right there. Right there. Next, we can actually start calculating mass percentages. Now, in the example, I already calculated that, I already calculated the mass of carbon. Notice I have 24.02 grams of carbon. Well, mass of the desired element, that's the mass of the desired element. If I'm doing the mass percentage due to carbon, mass of the desired element divided by the total mass of the compound. And so that will look like 24.02 grams of carbon divided by the 46.08 grams, which is the mass of the whole. I'm going to divide that out, multiply it by 100. I get 52.14%. And so 52.14% of this compound by mass is carbon. And then we would simply carry this out for hydrogen. I would take the mass due to hydrogen, which is the 6.06, divided by the 46.08 and multiply it by 100%. And then I would take the 16.00 grams divided by the 46.08 grams, multiply it by 100%. And I would have my percent composition due to each of these 3 elements. Now the only thing that I would point out, when you were to add up all 3 of these, you would need to equal, actually I'm going to say about 100%. Don't freak out if it's 99.98 or if it's a 100.5. Don't freak out if it's not exactly there, because we are only going to 2 decimal places. right? So we need to get to pretty much 100%. That's a good way to double check your work.